Hello and welcome to 8.4, where you guys will be learning about independent events. And here's the definition for independent events. It's the occurrence of one event that does not affect the occurrence of another event. So an example of that would be rolling a 1 on a dice and then choosing an ace at random from a deck of cards. What I roll on the dice has no effect at what I pull out of a deck of cards. And so that would be an example of independent events. And the way we can write independent event is that we mostly write a probability of A and B, although probability of A intersection B will also be something that we use to help find independent events. Now, the independent probability equation. In order to find the probability of an independent events, what we're going to do is we're going to find the probability of A and then multiply it times the probability of B. And we'll be doing an example of that here in a moment. Now, to determine if events are independent, then if the intersection of A and B and the probability of A and B are the same answer, then we will have independent events. And once again, we're going to be doing an example to show that. So, our first example, example 2. You spin the spinner, which is going to be over here. You spin a spinner 2 times. And we want to know what is the probability that you spin an event on the first spin, an even number on the first spin, and then you follow it by an odd number on the second spin. So we got 2 events here. We have an even number on the first spin, and then our second event is the odd number on the second spin. So I'm going to find the probability of spinning with only even numbers. So we're going to work with the first event and find spinning even numbers. I'm going to look over here to see how many even numbers I have. I have a 6, so that's 1, 8, that's 2, and 12, that's 3. So my probability of spinning an even number is 3 out of 1, 2, 3, 4, 5, 6, 7, 8 numbers. So the probability of spinning an even number is going to be 3 out of 8. Now, for the second probability of event B, or spinning odd numbers. So I'm going to look over here again, and I'm going to count how many odd numbers I have. So I've got 1, 2, 3, 4, 5. I've got 5 odd numbers. So the probability of spinning odd numbers is going to be 5 out of 8. Now, to find the overall independent probability, what we're going to do is we're going to take our event A times our event B. So we're going to take 3 over 8 times 5 over 8. And when we do that, we get 15 over 64. So what that tells us is that, and if I were to reduce that into a percentage, it's about 23%. So what that tells us is that 23% of the time, the first spin will be an even number, and the second spin will be an odd number. Now, the next example that we have is this. There's a little bit more information on this one than it was on your sheet, but an airport employee collects data on 180 random flights that arrive at an airport. The data is shown in this table over here. Show that flights arriving on time and flights being a domestic flight are independent events. So, once again, I've got 2 events or things that are happening here. We have flights arriving on time and flights being a domestic flight. So, I'm going to first find the probability of our event A, our flights arriving on time. So I'm going to come over here and I'm going to see on time how many flights arrive on time. And according to this, there's 162 flights that arrive on time. And there's 180 flights altogether that I'm dealing with. So the probability of a flight arriving on time is going to be 162 over 180. Now, our event B is going to be the flights being a domestic flight. So I'm going to come over here. I'm going to look and see how many flights are a domestic flight. And I have 120 flights that are domestic. So my probability of flying on domestic flight is 120 out of 180. Now, I want to find the probability of A intersecting B. So I want to find what the probability is of a flight arriving on time and being a domestic flight. So looking over here, I'm going to find where domestic flight and arriving on time kind of intersect, and that's right here. 108 flights are domestic flights that arrive on time. So the probability of those two things occurring is going to be 108 over 180. Now, to prove that these are independent events, I need to find, now that I've found the probability of intersection, I need to find the probability of A and B. And so if I discover that these two numbers are going to be the same, then we do have independent events happening. So what I'm going to do is I'm going to take the probability of A, which is 162 over 180, times the probability of B, which is 120 over 180. And I'm going to multiply that out, and I'm going to get some big numbers, 19,440 over 32,400. And so right now, if I were to look at these two numbers, it doesn't appear that these are independent events. What I need to do is I need to make sure that I reduce both of these fractions down. And if I reduce this fraction down, I'll get 3 over 5. And if I reduce this fraction down, I will get 3 over 5. So that is telling me that these two events are independent. Just because my flight arrives on time does not mean that it's a domestic flight. And just because I have a domestic flight does not mean that I'm going to arrive on time. So that's what the independent variables are telling us in this problem.